What we're going to talk through today is we're going to go through and show you some of the tools and techniques Bill and I use to try and make life a little bit easier. These are going to have more of a network focus to them versus host-based for the most part. But we're going to try and make folks a little bit easier. We have a PDF with a summary of the commands and stuff we're going to be using that's going to be available in, like we said, the Discord content channel or the resources channel through Zoom. And I'm going to jump up first. We're giving each other 5 minutes each. So I just clicked off my 5-minute timer. And the idea is for each one to go through, do our description in 5 minutes, and then hand it off to the next person. So the first tool I want to talk about is Smart TTY. This is something I literally use constantly every day. You can see one of the nice features about it is I can save every different system that I'm going to need to have SSH access to it. So Smart TTY is an SSH tool. It gives you terminal access. You can do file sharing. What I like about it is it's wicked configurable. So I can go in and I can define fully qualified domain name, IP address, what I want to connect to. I can log in for the first time using a password, but then I can tell it I want to use public private key after that, and it'll automatically install my public key onto that system. And in fact, you can even go in and use a different public key on every single system if you want to do that. So, you did use a different public private key pair for each individual system if you want to get that crazy with it. The other thing I like about it is that I can enable it keep alive. Sometimes I have my SSH sessions hanging out there for a long time. So it's nice to have a keep alive go off like every 5 minutes or so. That way it doesn't time out in firewalls and stuff like that. So the configuration on this is pretty cool. The other thing you can do is I can have a descriptive alias. So rather than just having an IP address or a fully qualified domain name that I may forget what that actually is trying to do for me, I can go through and I can give it some sort of descriptive name that'll be useful. To connect up, you literally just double click on the icon and then bang, you've got a session that opened up in a different window on me because I usually use a different window for that. But you can see here it goes in, it just kind of starts things up. What's kind of cool about it is if I need a second session, let's say I'm doing something in this terminal and it's going to take a while, so I just want to open up another terminal real quick. I can go click the plus sign, boom, I've got a second terminal running. And you can see down the bottom here, I've now got 2 tabs connected to the same system. If I need to connect, if I want to connect to a different system for some reason, I can go to the little sun tab here, click that, and here's my list of all the different hosts that I have. So I could open up a new tab that now goes off and points at a different system beyond this one. I can also go through and open up the file system and use this to navigate my way through instead of using the CD command. So I can go in and just kind of navigate things that way if that makes life a little bit easier for me. But what I really, really love about this tool is it makes transferring files super easy. So let's say I wanted to be able to, download a file from this system. If I click download, I can then just go in, browse what I want to pull in. So maybe I want, I don't know, the Zeek cut file or whatever. I just go in and tell it, yep, download that to de-download. It's already there. Yes, go ahead and download it. And then bang, you can see it just kicks off and it keeps track of what gets transmitted there. I can also do uploads. I can also do full directories of each. So if I have a whole directory structure I want to pass off, I can do that. Excuse me. I can go in, I can manage my Linux packages directly through this instead of having to use like app at the command line if I want to go through and do it that way. So yeah, so as far as like an SSH tool that runs on Windows that is simple, easy to use, gives you a lot of flexibility, Smart TTY is the way to go. And with that said, Bill, I'm going to hand it back to you and I'm going to give you an extra minute.
Oh, fantastic.
Because that was just that efficient.
I love it. Perfect. So I love that package. I think they've really thought a lot about how people want to use SSH and did a really good job with it. So on Windows, that's my go-to as well. On the Linux side, the part about public keys and making easy connections to the remote end is that the setup can be a little bit annoying. So what I've done is just worked on a tool that will set up everything for you. On this system, I want to be able to connect to another computer, but I don't want to have to do all of the setup steps. So if I use the tool called SSH prep, which is number 2 on the handout, the steps to install it are listed there. I'm not going to go through those. You can just run those command on a Linux system. But if I use SSH prep, it will generate a key for me. It'll ask me for the passphrase. Well, no, apparently I need to use something longer than that. There we go. And then it'll ask me for that passphrase to actually set up the connection. It'll connect me to the other end. And it will ask me for the password to get into the remote system. If this seems like it's a lot of work, just hold on a second, because in the end, we are going to, hold on. I have to convince my, okay, hold on. I got to type it.
PASS.
Thanks, Chris.
WORD. Oh, capital P, sorry.
Yeah.
And then the number 1 at the end.
Oh, Chris, you're such a good help. So what it does is it lands you right back at the original system. And now if you take off the word prep and SSH to the remote system, your key has been created. You're automatically logged in to the remote side using that key. It's all done for you. And if I disconnect and I reconnect, I'm back in without any effort whatsoever. It also sets up the config file. So if I have other settings that I want to add, the system is listed here. I can edit this file. I can add additional fields. I'm trying to make this the simplest possible way to set up SSH keys from one end to the other. I think this comes awfully close. And Chris, I'm going to send it back your way because I think that is basically the whole thing.
Cool. I'm going to ask you one quick question before you drop that.
Please.
In that config file, you had 2 entries for the same fully qualified domain name, IPv6, IPv4, are the 2 options.
Yep.
Which one is it going to pick by default?
If I just type elroy.aihosted.com or this IP address, it's going to use this block. If I type elroy.aihosted.com -v6.
Got it. I missed those were different.
Or this part, then it'll pick the other one. And there is actually another IPv6 address associated with this. I would probably go in and change this IPv4 equivalent into the actual IPv6 address of that system.
Because that's something we are all looking forward to, is having to type in IPv6 addresses. Yes.
That's why you never want to do it anymore. It's all handled for you. All right, Chris, all yours.
Awesome. Awesome. Let's see. Let me grab back that screen share. Cool. So what I wanted to kind of talk about next was tshark. So I think folks are kind of familiar with tshark. You can go through with tshark, and actually, let me go back to my first terminal, because that's going in and just kind of showing me where I'm working all the time, and I don't need to see that. So if I say tshark -n-r, the name of a pcap file, and I'm just going to pump it through less. I think most people are kind of familiar with this. So I can use tshark to go in and read a capture file, and it gives me little summary information here of everything that goes by. I can see this is involved with an HTTP session. You know, I get some summary information. If I want to see more data than that, I can go in and I can use -v. But the problem with -v is it's freaking huge. It is capital V. Am I getting this mixed up with TCP dump again? There we go. This is all one packet, right? So if there's a piece of information I need to see that doesn't show up in the summary, you know, most people know I can do -V and get a summary of it. And well, yeah, no, this is too much information. So what if I want to go in and just specify specific pieces of information I want to say? You can do that with tshark, which is kind of cool. That's a feature that's not available in TCP dump. What fields are available? Well, one of the things you can do is you can type in tshark dash capital G, and then pump that through less. And then that's hard to read. So I'm going to say less space dash capital S so that it scrolls everything off the side of the screen. And dash X25, it'll give me 25 characters per column. And oh, hey, look, that's now a whole lot easier to read. Any column labeled as P means this is a protocol. Anything that's labeled as an F means that it's a field. But what this is going to identify for me is all the different fields I can go through and I can specify. That's these here. So these are your display filters when you're in working with tshark. So you can go in and you can say, you can search through this whole thing. One of the things you can do is you can use, excuse me, you can go in and you can tell it specific things that you want to go in and look for using something like grep. So for example, I'm going to just start copy pasting commands because it's a little faster. tshark-g, that's what I did before. I'm saying grep DNS period. And see this little backslash here? All that does is that tells grep, hey, this period is actually a period. It's not a wildcard. When I run this command, now what you'll see is everything it's showing me is a DNS command, or excuse me, it's the DNS display filters. So what I can do here is I can say, hey, if there's only one specific field I want to say or two or three, I can go in and I can do that. So for example, let's say the only thing I want to go in and look at is the DNS queries that are taking place on my network, right? If I want to do that, I can go in and I can say tshark, read that pcap file, dash capital T fields tells it don't print out your normal summary. I'm going to tell you specifically what I want you to print. And then I'm going to say dash E DNS.name.query. And that's it. Now you can do multiple dash E's. So you could do dash E IP.src, dash E IP.dst for source and destination IP addresses. I'm going to keep this easy and just say, hey, let's look at what are people trying to look up via DNS. And then this is my filter that says only do this with DNS traffic. So if it's an HTTP session going to TCP port 80, don't bother looking for a DNS query field. There isn't going to be one. So this just limits it to make sure we're looking at DNS traffic only. And then I'm going to pump that through less. And when I do that, you can say, hey, here's all my DNS queries that took place. So this is all my queries that are in that pcap file in the order as they show up within the pcap file itself. Well, what if I want to see some metrics off of that? What if I want to go through and I want to say, I don't want to just see individual queries. I want to see, let's say, my top 10. What are the top 10 things people are looking up? And this is one of the nice things about using these fields, because even if this information did get printed out in the summary, well, now I've got a bunch of information there I don't care about if what I'm looking for is the top 10 things I'm querying. So, excuse me. So, this allows me to just get the data I want to work with, and that's it. So we looked at what that looked like, right? I just saw each of the individual queries. So a lot of this command up to here is the same. What I'm doing now is I'm sorting it. So remember before it was showing all the individual queries, and sometimes the same query was done, but it was maybe 10 queries away from each other. Sort's just going to go through all of that and saying, rather than printing it out all out of order, sort it first so that it's all, the same query shows up one line after the other. Then what I'm doing is that I'm running it through the unique command. The unique command says, hey, if there's 10 entries, only print one. If there's 5 entries, only print one. If there's 1 entry, only print one. So that just says, hey, I don't care about the repeating patterns. Dash C says when you remove them, count them. So if the originally was 10 entries, only print one line, but print the number 10 at the beginning of it so I know there was 10 entries originally. Then I'm saying sort dash RN. Dash R means do a reverse order sort. So normally numbers will get sorted from lowest to highest. This is going to sort from highest to lowest. Then what I'm going to do is I'm going to go through and I'm going to say dash N sorted as a numeric value, pump it through head. Head will say print out the first 10 line entries and that's it. Once I go through and run that, it takes a little bit because we're reading a PCAP file, but here are my top line entries. So here's the one I was looking up the most, 298 times, config.edge.skype.com. Clearly, there's a lot of traffic going Edge on here, but I can do this with any fields. This is just an example with DNS. You could do it, like I said, source IP, destination IP. And if you need to know what fields can you print this way, tshark -G. And that's it. Back to you, buddy.
All righty.
Go ahead and steal the share.
I think, let's see if that's going to work. Did that come up?
Yes.
There we go. Great. One of the things that I have commonly want to do is run long commands, and I don't want to have to keep the terminal open. So picture me compiling a large software package, and I know it's going to take 5 or 6 hours, but I want to go home. So I don't want to have to keep a window, an SSH connection open to that remote system to do that. So the tool we're going to use is called Screen. It may be already installed on your system. And I did have a typo in the slides. My apologies. It's sudo yum-y install Screen, not -u. But once that package is installed, we're going to run a Screen window. And here's how you set it up. I'm going to give all of these a name so that I can keep them straight. I may have multiple screen windows that I keep open. So let's do system status -r. Wait a minute, I just got a command prompt back. Exactly right. This is a separate command prompt that I can connect to and disconnect from, and we'll see that right now. So I'm going to run a command that I know will update the screen pretty regularly. And here is that system. It's going to keep spitting out output and spitting out output and spitting out output, but I know I've got to go home and get dinner. So the keystrokes that I press are first Control A and then the letter D. And those two keystrokes, one right after the other, will disconnect me from that. So how do I know it's still running? Let's reconnect with the exact same command that we used to set it up in the first place. And here we are. That same program is still running in the background. It never stopped. So I can press Control A, Control D. I can shut my laptop entirely down, drive home, connect up to my home wireless network, reconnect to the system in question, rerun this command, and that command is still running. So that's the beautiful part, that I can have long-running commands. The URL that I've got in section 4 of the handout has a couple more things to it. I will point out one more thing. If I'm sitting at a remote system and I do SSH test user at do-ce7 screen-s system status -r. If I have the command that I want to run inside SSH be that same screen thing, I go, sorry, it's nothing like a demo. For some reason, that's not going to, oh, hold on. SSH-T, here we go. I get that same command back, and then when I press Control-AD, it shuts down the SSH session. So you can do screen on your local system, and you can do screen on a remote computer and connect directly to the screen session. Chris, that's yours.
Cool. Yeah, so someone was asking, are they gonna, what's the that? Are we only going to do Linux today? Is there going to be any Windows stuff? Actually, the tshark stuff I'm showing you will work on Windows as well. The commands will be different. You don't use grep, you use find. Some of that stuff will change up a little bit, but the core tool itself, tshark, works the same way on the Windows side.
And Smart TTY was definitely a Windows tool that really makes it possible to connect up to any other SSH-based system.
Yep. And Bill, somebody had a question. What are the advantages of screen over tmux?
Screen and tmux are absolutely parallel tools. Tmux uses a slightly different protocol for connecting. It uses UDP packets instead of TCP, but they're very similar. There's no reason why one is absolutely better than the other.
Cool. Cool. Awesome. So in this one, I'm actually going to get into a bit of scripting. So what I wanted to talk about is sometimes you have a reason to generate traffic patterns, right? Sometimes we may want to do some testing. One of the most common ones I do these days is I go through and I want to be able to go through and create something that looks like a C2 channel. Right. And then I want to be able to see, is the way the perimeter is set up, does it have the capability to be able to detect that type of traffic? And there's a couple of ways you can go about doing payload creation if you want to. So this is one of them. So this is just a simple little script called beacon test. And all beacon test does is I've got a loop here, right? So between while and done is a loop. So in my while loop, well, my do loop here, it runs the curl command. So curl is my command line web browser. You can use any equivalent to that. And what I've done here is I've just set a user agent string that I know will be me. You know, in other words, if I want to be able to tag this stuff versus regular HTTP traffic, I can go in and look for any payloads going by that have the word Atari 7800 in it. I'm sure anybody who's been up there remembers the old Atari 78 web cartridge. You know, sometimes you couldn't get on the internet, so you had to use an eraser on the contacts when you plugged it in. But that was our first web browser, Mozilla version, .0001. It was still alpha code back then. But I'm kidding. There was no web browser that ran on the Atari 7800. So again, this will be something you will never ever run into in the wild. But again, I know it's me anytime I see Atari 7800. So this curl command is just saying, hey, I want to do an HTTP session to a site. What I want to connect to is $1. That's a variable that will feed it. And I'll show you that in just a second. And I want you to change the user agent string from being the one that curl normally uses to being this. Don't print anything out on the screen. Don't care about that. And then here's where the fun comes in. I've got a sleep function here. So I'm telling my do loop, I want you to pause for a certain amount of time. Now I'm using the tool shuff for that. And the reason I like to use shuff instead of random is I found shuff is more random than random. Hey, it's Linux. You run into weird stuff like that, right? -I defines the range that I want to be able to select a number from. So in this case here, I'm saying pick a number between 2 and 5 seconds. So this is going to create a very fast beacon. It's going off every 2 to 5 seconds. If I was actually doing this as real testing, that would probably be more like 200 to 500 seconds. Anybody can catch fast beacons. But hey, what if it's waiting 5-10 minutes in between each big beacon signal? Can you still detect that? That's the one we care about, right? So I'm just doing this for the sake of this testing, but normally, like I said, this would be up around 200, 500, and that allows me to throw a little bit of jitter into my C2 connection as well. -N1 says just pick one number. So what'll happen is curl will execute, and then shuff will pick a number between 2 and 5. Let's say it picks the number 3. Sleep will sleep for 3 seconds, and then it'll loop back up and run curl again. And then it'll loop back up and run curl again. And it's pausing a random number of seconds each time. This is a great thing to run through screen, by the way, that Bill was just showing off. So if I go in and I say beacon test 127.0.0.1, just to go in and cut up, I have to get the IP address right, Chris. .0.1. I'm just sending this to my loopback address for now. But you can see here, I've got TCP dump running. And it's looking for some repo stuff. I had this running too long, I guess. Yeah, here's my GET request right here. Don't have a whole lot of data in it, but I can see here, I had Netcat listening on port 80, and what Netcat got was a GET request using protocol 1.1. And the user agent string was the one that I had gone through and defined. So there's one way I can go in and I can go through and I can use that to send data. Another fun way I can use, let's go back here. So I'm going to kill this process. I'm going to go in and I'm going to just create a text file. So let's say I want to send it to some random TCP port or something like that. And actually, let me go back here, kill TCP dump real quick, and I'm going to add the -X option. So we see payloads. And I just used echo to create a file named foo.txt, and it's going to have that text in it. So if I cat foo, because we always loved a cat foo, this is my happy payload. Great. Now what I'm going to do is I'm going to use hping to go through and send this traffic. So the hping command I'm going to use in this example is just sudo hping, right? Because hping doesn't use the IP stack in the system. And by the way, there's a version of hping 3 for Windows as well. So if you're on Windows, go out and find it. You can do the same type of fun stuff. hping doesn't use the IP stack built into the system. It does what's called a raw write to the wire. So it needs root level access or administrator level access. -1 says I want to do this as a ICMP packet. -E says I want to populate the payload with the contents of this file, that file that I had just created. -D100 says I want to use 100 byte packets. And -C3 says just send 3 of them and stop. So now if I hit enter on that, let's see, PASSWD password. There we go. Missing host argument. Oh, yeah, duh. I have to tell it where I want it to go. There we go. So you can see I did -1. It defaulted to sending echo request, echo reply packets. But if I come back here to my TCP dump session, you can see my echo request and echo replies have that payload in it. This is my happy payload. So I can even embed stuff into the payload of ICMP packets if I want to do that. Okay, one last one real quick is I can also go through and use, do this type of thing to move payloads around if I want to. So I'm going to create a new file. This is my awesome text file, and we're going to name it send.txt. And now what I'm going to do is I'm going to use netcat to actually transfer this file. So I'm going to use netcat to both set up a listener. So netcat, if you're not familiar with it, is just a raw socket tool. It allows me to send and receive data in raw format. So I'm telling netcat, I want you to listen on port 1234, and any data that comes into that port, pipe that into a file named received.txt. Now what I'm going to do is in this other screen, I'm going to use netcat again, and I'm going to say, I want to, let's see, netcat, I need to give it a timeout -W3. If you don't get any more data for 3 seconds, assume this connection is closed. 127.0.01 is who I want to send it to. The port we had told netcat on the other side to listen to was 1234. And then we want to pipe into that send.txt. So now when I go through and I run this, we'll see netcat comes back with the command line. And now when I go over here, I never launched that. Okay, now we've got that running. Now we'll run this again. This will work this time for sure. Yeah, see, it paused for a second. So it paused for 3 seconds, and then it came back. And now I've got a file named receive that has, this is an awesome file in it. You can transfer binary files this way too, by the way. Cool. And with that, Bill, back to you. I think I may have gone over a minute there. Sorry.
Never a problem. That's really handy, especially if you're on a system where you're doing forensics and you don't want to touch the drive or touch it as little as possible.
Yes.
netcat is a great way to transfer stuff off because it uses basically a built-in tool with very little effect on the system.
Yeah, I've done a full disk copy, piping it through netcat on a Windows system to netcat on a Linux system. And, you don't need to worry about protocols or anything else like that.
That's where you really want something that'll run long-term.
Yes,
Fantastic.
exactly.
Hey, my next tool is available for Mac, Windows, and Linux, and it has to do with system visibility. The tool is called gkrellm. I'm not quite sure how to pronounce it. I'm sure I'm getting it wrong somewhere. But once you've installed it on any of those operating systems, just start it up. And what you get is a thin window that I will have running on my system all the time. What this gives you down at the bottom are a couple of very basic things like how much memory is available, how much swap, how much disk space are available on different partitions. But up top, I get a display of the previous 60 seconds of different pieces of my system. So this system has 8 processors, and I can see those processors up top and how heavily they're loaded. I have another window that shows how many processes are running, how much data is being sent to or received from different drives. So I can see down here that because there's data heading out to an old hard drive called Seagate Desktop that my backup is currently running. And then finally down here, I have Ethernet 3. This shows the data moving in and out of that network interface because I'm running a Zoom call, of course. Why does this matter? Because I need to be able to know how a system is running. Where is the load? Where is the bottleneck that's slowing me down from accomplishing something? gkrellm is just perfect for that because it shows all of this stuff live on my system. You can run it remotely over SSH. It's a great way in a data center to be able to keep track of critical systems. You just leave a monitor up with 1, 10, 100 copies of gkrellm on a large monitor, and you can always look over and see if there's a spike that you don't recognize. Well worth it. And if you need to configure it, the F1 key lets you bring up, hey, I only want to see these particular screens, or I want to change the configuration of it. Rinsler, the tool is called gkrellm, gkrellm. And if you want to be able to write something out to a log file, there's a gkrellm daemon that you could connect to and poll for values. That is way out of the scope of this particular class. But yeah, you can have the daemon running and then simply pull that data out and write it out to a file. Chris, it's all yours. And
Cool.
you're on mute.
Thank you, Bill. Yep, I was on mute. Awesome. Bounce back the share. Okay. So continuing on the theme of dealing with command and control stuff, right? Because, hey, threat hunting, that's kind of the theme of the server. One of the things that's kind of nice is to be able to go in and get just kind of a sanity check to kind of figure out, does something actually look beacony or not, right? Like let's say you're in a PCAP file, you're looking at some data, you're seeing 2 systems talking to each other, and you're kind of wondering, okay, is it busy just right now? Does this have C2 characteristics to it? And of course, Reader and AC Hunter are designed to do that, but you may not have AC Hunter or Reader available all the time to you. So what do you do? Well, I've written up some shell scripts around that. So let's take a look at the first one. So the first one is called beacon-tshark. So this is designed to take tshark data, right? It's designed to take data that's in a pcap file and parse that to help you figure out, does it look like a beacon or not? So the beginning of the file is all documentation, right? This just goes through and tells you this is how this file works. But let me kind of work you through it on the bottom. So the syntax here is to type beacon/tshark space, and then the name of the pcap file that you want to go through and parse. So when this script runs, the first thing it does is it says $r$1. What's the file that you want to go through and parse? Then it goes through and says -t fields. That was the one we were just talking about, right? Remember I said you could use that to go through and extract out just the fields that you want to see. And the fields that I'm extracting are the frame time, when was this packet seen, source IP, destination IP address. And then I'm also taking as a command switch, the IP address that you want to work with. So the syntax is beacon/tshark space, the name of the pcap file, and then space, the source IP, or one of the 2 IP addresses, and then the second IP address that you want to use. So beacon test, pcap file name, first IP address, second IP address. You can be source destination, doesn't matter. It'll kind of check them both. Then what it does is it looks to see, hey, I only want to look at packets that have the SYN flag turned on. So we're just looking at the first packet in a session. And the acknowledgement flag needs to be turned off. So that's going to give us first packet in a session. SYN on, ACK off. That's my first packet. Is it's going to go through and it's going to print out a timestamp and the source and destination for each of these. And then what I'm going to, then what this does is this goes through and this cuts out the hour field that got printed. Then it goes through and it extracts it down a little bit more. And the second cut command is just kind of rearranging the printout and how it looks. And then unique C is going through and is counting up how many connection attempts were seen each hour. If that sounds a little weird, I'm going to show it to you in just a second. But I also gave you a second one that's specifically for working with Zeek logs. So let me show you that, because this one's not that different. So this one, instead of going after the pcap, goes after con.log, because that's what Zeek, where Zeek stores its connection information. It uses Zeek cut to pull out the exact same information. What's the timestamp, source and destination IP address? I'm using grep here to identify the fields that you've handed to it as a command line switch. So source and destination IP address. We don't need to specify a pcap file because this is Zeek. So it's only going to go looking for the con log in the current directory. Then what I do is some formatting here, right? I'm changing the date format so that everything is separated by colons so that I can then go through and use that to cut out just the hour field. Then I'm using unique C to count it. TR is just going in and moving some blank spaces. And then in this one here, I'm just simply saying print out the hour and then the quantity after that. Okay, I know that seems a little weird, right? Because I kind of went through that quick because we're trying to stay within our little 5-minute window. But let me walk you through the second one. The first one works basically the same way, but I'll spend some time on the second one here. So this is my con.log file, right? Here's my timestamp information here. Now this is number of seconds since, January 1st, 1970. The -D switch I was using actually converts that to a regular format so I can extract the hours out of that. But here's my source IP address information. Here's my destination IP address information. So it's just going to go in and it's going to parse that stuff out of that file. So if I go in and look, let me pick one here. Okay, our first one, 68.183, 138.51. I see it there. It's TCP 80 traffic, so it's HTTP. Got a couple more there. I can see it's going off a lot. Now, is it a beacon or not? Well, just looking at the raw data like this, it's kind of hard to tell, right? Now, if I run it through that script, so I'm going to say beacon data, and then I have to specify one of the two IP addresses. So 10.0.2.15, I think was the source IP I was using. If this doesn't work, that's probably wrong. But the IP address that we flagged was 68.183.138.51. So now when I run this script against my Zeek logs, here's what this output, here's the output. Now, what does this mean? This means that the first hour in that pcap file was hour 19. So it was the 19th hour of the day. And during that hour, 28 connections went off. And then during hour 20, I had 119 connections. And then it dropped to 44, dropped to 1, went back up to 76, and then it went to 119, and then 120. And now we're wrapping past midnight in this pcap file. And look at this, 119, 120 each hour. In fact, one thing I'm curious about, if I look at my 19th hour here, I had 92. If I go back to my first hour, I had 28. 92 plus 28, oh wait, that's 120. The same thing we were seeing each of these hours. So when we talk about beacons, right, when we talk about a command and control channel calling home, that is calling out on a regular basis. Well, this is clearly calling out every 30 seconds through the entire pcap file. So is this something that I need to analyze as being a potential beacon? Oh, absolutely. And I've done it with a simple little shell script. And I didn't need reader, I didn't need AC Hunter. And with that, Bill, back to you.
Fantastic. I'm going to switch over a little bit to the task of moving files back and forth between systems. If you remember, Chris's first example was using SmartTTY on Windows. On Linux and other Unixes, the task of transferring files back and forth is done with the SCP, Secure Copy tool. But I want to point out a slightly better one called rsync. This was written by a gentleman in Australia who was writing the Samba code for Linux and was constantly sending mirrors of the Samba repository over to the US from a connection that was probably a modem or slightly better. Yeah, I believe Jeremy Allison. That's no, I can't remember the name. I'll have to look that up. Somebody wants to look up the original author of Samba. That would be great. So what he said was, look, I've got all these files that don't change, and I've got a couple that change from time to time. Why don't I instead you write a tool that will look and see if I've got the file on the other end and if it really needs to be transferred again. So the tool is called rsync. In the handout, I've got a couple examples of how this is done, but here's the basic premise. rsync-AV, I want to verbose say I want to see a little bit more detail, -E space SSH. That says rsync, instead of connecting directly on an obscure port, why don't you just go over an SSH connection? So we have encrypted and authenticated traffic and maybe even compressed. And then I want to list the file that I want to send. In this case, I've got a file called thunt labs on this system, and I want to send it over to the other one. So I'm going to send this over to the temp directory on the remote computer. So when I start this up, I'm actually going to add --progress and --partial to this. You don't have to do that, but I want to show how this works. The progress entry will show you this status update showing how fast the transfer is going right now, how long before it's finished, how far we are done, and how many bytes have been sent. So in just a couple of seconds, this is going to finish up and I'll be able to look over in /temp. Until it's done, there we go. You see how we've got a file called thunt-labs.tar.gz over on the root system? That's sent over. I mean, that in itself isn't all that interesting, but here's the interesting part. I come back 2 weeks later and I forget I sent it. I want to send it over again, and this will connect up. It'll see that the remote system already has it. It has the same timestamp. It's not going to send it again. So this is just beautiful, especially if you have a large tree of files that you want to send from one end to the other. So instead of doing a file, the way you usually do it is /home/test user /some data. And I have to end that with a /. And then I'm going to send it over to the remote system to home/test user /incoming. And I'm going to end that with a / as well. And what that will do is it will say, take all of the stuff from here down, everything under some data, send it over to elroy.aihosted.com and place it in home test user incoming, making that entire tree look like the source. And this is beautiful if you've got a set of files that you need to send over. This works across operating systems. rsync works on Windows, on Mac, on Linux, on FreeBSD, on everything. It's usually packaged with your operating system, although you may have to add it for Windows. It is a really handy tool and it saves you a whole bunch of bandwidth. All right, Chris, that's back to you.
Well, cool. Thank you, dude. Right. Yes, I want to steal it from Bill. Awesome. Awesome. So yeah, so this will be the last one for me. So in this one, I kind of wanted to go through payload decoding. I wanted to go through and kind of talk about, like, because I was showing how to move data around the wire. Okay, what if I want to go in and, kind of look at that payload? And there's tools out there like ngrep, which are awesome. But one of the challenges with ngrep is that, one of the challenges with ngrep is the fact that it still prints out header information. What if I'm only trying to go in and find the data stream? Now, a lot of folks are familiar with Wireshark, and you may even be familiar with Wireshark's ability to follow streams. So I can select a TCP session and say follow TCP streams, and Wireshark will go through and knit all that data together for me, which is awesome. It's an awesome function. The challenge with it, though, is it only works on TCP and UDP. It doesn't work on ICMP. So what I'm going to show you works on TCP, UDP, and I'm going to make this hard and actually use ICMP to go through and do this. So let's just start simple, right? So I'm going to say tshark -r, my ICMP cap file, pump that through less, and let's see what we got. Yeah, we got Chris's fat fingering things. So we've got a bunch of ICMP packets going back and forth. I've got my echo requests, echo replies. It's going back and forth between two systems. And hey, it looks like if I kind of page through this list, it looks like we're pinging things a lot. Okay, we're pinging things a lot. Why are we pinging things so much? Well, I could go in and try and get a look at what's in those payloads going back and forth. Is there anything there that I need to be concerned about? And for that, I'm going to use TCP dump instead of tshark, just because remember the challenge we had with tshark was I either get no payload or I get 5 pages per packet, and I have to look at everything. Tshark gives me TCP dump gives me a little bit better visibility, right? Because it'll go through, it'll give me that summary, but here's my payload information down in here. And I can see that, okay, yep, it looks like it's a blank payload. That's not something any of my operating systems usually use. But, wait, what's this? I've got an echo request that has dir volume in drive C is OS volume serial number, blah, blah, blah. What? Directory of C temp, what? Wait, there's real data in these request packets. What's going on here? Quick, let's go to Wireshark and follow. Oh, no, wait, we can't, right? We said we can't follow an ICMP stream. Now, I could just keep paging through here and keep trying to stitch stuff together, right? Like this is just garbage. But, this here is when it's the actual stuff that's in the payload. And I could try and visually do this. But what if I just want to stitch all the payloads together and be done with it? What if I want to go through and just say, no, just show me the payloads, don't show me anything else? And I don't want to be limited by Wireshark that will only do this with TCP and UDP. Well, what's kind of cool is tshark does this. And what's kind of funny is tshark is the command line implementation of Wireshark. So here's something you can do with tshark that you can't do with Wireshark. Go figure. So tshark, so it has the ability in the code. They just haven't bothered to give it to the Wireshark folks yet. I guess they've decided, oh, folks at the command line, you know what you're doing. We'll give you this feature, but GUI folks, yeah, we'll get around to you eventually. Yeah, that must be it. That's what the programmers are thinking. Okay, enough being a pain. So I'm saying tshark -r, read this capture file. Hey, look at this, -t fields. So I'm specifying fields again. And the field I'm specifying that I want to print out is the data field. That is a field. That's a valid field. So I'm going to go in and tell it I want to print -e. I want to print out the data field. And then I'm pumping it through this tool here. -xxd. Let me actually tell you what. Let me show you why we want to pump that through xxd. So I'm going to take this and I'm going to pipe that through less. There's all my payloads right there. And actually, it'll look even better if I go through and I say -S. Then we get 1 per line. Oh, cool. Hey, oh, did you see that? Wow. Oh, yeah. And there, see, that's suspicious, right? No, it's in hex. Most of us don't speak hex natively, right? So what we want to do is we want to be able to convert this to ASCII because that's the basis of the language that most of us tend to use. So that's what XXD is going to do for us. If you look up XXD, XXD takes ASCII and converts it to hex. Well, we've already got hex. We're trying to get back to ASCII, right? -R, do it in reverse. Then I'm going to say -P, print out plain text. Now let's pump that through less and see what we get. Oh, look. So this looks like somebody typed in the dir command. Why is dir twice? I'll bet anybody who's as old as Bill and I and remembers Telnet knows why dir shows up twice. It shows up twice because somebody has a terminal session running with the target system. And with a terminal session, whatever you type always gets reflected back. So if I type dir up to the server, dir server reflects it back to my terminal so that I can see it on the screen. So I'm not seeing what I'm typing directly. I'm seeing what the server is returning back, which is what I'm typing, if you want to think of it that way. So somebody's typing the dir command and oh, look, they're getting dir off of Windows. These are Windows directories. These are Windows files. What's this? Oh, wait, somebody ran the task list command. The task list command. Oh, what show was that? There was some kid who used to like repeat things and whisper, and it was kind of creepy. You know, task list, task list. Yeah, they're running task list. So they're seeing all the processes that are running on this. So what we originally thought was just ICMP traffic going back and forth is actually a command and control channel. And by extracting those payloads, and pull that back up for one last time, we can very clearly see. So this is taking place over multiple packets. What tshark and XXD is doing for me is it's knitting all of that together so it's very easy for you to be human readable. And with that, Bill, I am going to bounce the ball back to you. Oh, that's what we need. We need a little bouncing ball to go off as we're changing back and forth between you and I. Bummer. We'll remember that for next time.
You got it. Hey, that's really handy. The whole idea of being able to get better vision onto your network is exactly why we look at raw packets. One of the things that we spend a lot of time on is packet capture and analysis. And I want to show you one last technique for how to handle packet capture. If I run TCP dump on a remote system, and I say, just show me a summary of every packet that goes by, watch what happens. Remember, I'm SSH'd to this computer and I'm running packet capture on it. And all of a sudden, the screen goes crazy. Why? Because every time TCP dump wants to show me something, it has to send a packet to me. And then TCP dump has to look down at the network interface and said, oh, there's another packet. Let me show that. Let me show that. Let me show that. So in a couple seconds, I had over 65,000 packets show up. The problem is you have this infinite loop of TCP dump showing you a packet and then having to analyze that packet and then show you the next package and analyze that packet. So really what I want is to say, I don't want to see the SSH traffic to and from my computer. Let me throw that away. And this is where we use a feature called BPF, or Berkeley Packet Filter. If I put something at the end of the command line for basically every packet capture tool ever made, I can tell the operating system and the libraries on that computer to throw away certain types of traffic or only display certain types of traffic. So in this case, I want to throw away the SSH traffic to and from my computer, but I want to see everything else. So watch how this works. I don't want to see traffic which has that IP address at either end of the connection and is using TCP port 22. So this will look at both packets going to and from port 22 and to or from host 71, 233, 243, 197, which is where I am right now. If I run this, watch what happens. There's a little bit of traffic going back and forth. There are probably a whole bunch of people on this webcast who are like, "Ooh, let me try to log in." Or there are people who are trying to brute force passwords and are logging into that port. So I see everything else but that traffic. So this, in single quotes, over on Linux or Mac OS or FreeBSD, any of the BSDs, or in double quotes with WinDump running on Windows, are the filter that I want to apply before anything else happens. So this is just one filter. If you look at the handout that we've got over in #ACM webcast -content, there are a lot more examples in there, as well as pointers to do some blogs that we have talking about BPF, how it works, how you can use it, and some examples of command lines that do this. I think that's all I've got. So Keith, do you have any questions that have come in that we haven't covered so far?
None that I've really seen that either you guys have answered or the community in Discord have answered, which have been doing awesome, by the way. So thank you, everybody who's chiming in and answering questions.
Wonderful. Hey, thank you, everybody, for doing that. This should always be a team effort, and we do appreciate it. I'm going to add one more into the webcast chat. If you go to www.explainshell.com, I don't think we've specifically mentioned that today. That website is great when either Chris or I have come up with some really ridiculously long command line.
Yes.
And
We don't do that.
It would never happen. It really couldn't. But when we do, that particular website allows you to type in a long command line and explains the individual pieces of that whole pipeline. So this is a great way if you're looking at, like, I have no idea why he's using sort-rn. What does that do?
Yep.
And Explain Shell will do a really nice job of helping you understand the different components as you go through.
Yeah, the other thing you can do too is you can kind of deconstruct the command we gave you. So you can go in, so usually the command might have, hey, I'm going to do this and then pass it through, I'm going to do A, then pass it through B, then pass it through C, then pass it through D. Well, you can just go through and say, okay, let me run A. What does it look like? Oh, yeah, okay. Now let me run it through A and B. Now what does it look like? How does this get me a little bit closer? And you can kind of work through it that way. Sometimes I find that to be super helpful as well.
And Chris, if you don't mind, I'm going to do one shameless plug. If this is of interest to you, or you'd like some more time on Linux command lines, we have a bash scripting course over at www.antisyphon.org. And I'm going to apologize because I wrote and did that course.
He's going to apologize.
It is a shameless plug.
How dare you share your knowledge with the world, Bill? What were you thinking?
I know.
Yeah. Well, clearly this webcast must be close to over because I am almost out of kitty piddle.
And if you're out of kitty piddle, you're out of technical
when
content.
You're out of kitty piddle, the webcast is over.
That's right.
Awesome.
So apologies to
Keith
Chris's
Shelby.
dog.
Yeah. Yes. Getting scratched up trying to hold the cat over the bottle. Yes.
Yep.
So Shelby, Keith, anybody got anything else they want to toss in the 60 seconds we have left?
Not really. I'd just like to say thank you both for kind of shifting the focus away from like GUI software. You don't always need to like download some graphical interface to do a lot of this. And in fact, in a lot of ways, working with these tools on the command line is going to get you to the data faster.
Yes.
So
yeah, and there was some questions about like the stuff I was showing at the end, like where did that come from? Is it all in the PCAP? Yeah. So what I was showing you was that was a command and control channel that that was using ICMP echo request, echo reply packets in order to send the data back and forth. And the reason it's doing that is, if you saw a TCP 80 or a TCP 443 session and it's going off all the time, you might pay attention to that. If you're seeing what, echo requests, echo replies, you may look at that and just say, oh, that's somebody pinging something. I don't need to worry about that. The tool I used was ICMP shell. Very simple tool. Yes, it runs on Windows, as you saw. So it works on the Windows side as well. But yeah, go ahead and play with this tool. Folks were asking for the PCAP, even better, run the tool yourself. Because I think the experience of what can be done over ICMP will change how critical you look at traffic passing your perimeter. Cool, and I shared the link to that in Discord. And I think that's it.
I did just want to mention real quick, I did notice we have a few new people who joined us today who said they were new to computer security. And
Awesome.
if you are interested in threat hunting at all, we do a free 6-hour threat hunt training. We'll be running it at the end of February. It's in the resources tab on Zoom. I'll also share the link in Discord for everybody. Keith just did it. Thank you, Keith.
Yeah, Keith
And
is awesome.
yeah, if you can't attend it live, the recording from the last session is up there. But we will be running it again. It's the same deal as our webcast, so we'll chat on Discord and use Zoom, and we'll be doing that in late February.
Yep, but I don't drink kitty piddle when I'm teaching that class. So
Yeah. So
Fantastic.
hopefully we'll see you then or in another webcast coming soon. But thanks again, everybody, for joining us today.
and thank you for sticking it out through the craziness. Sorry, Bill and I just have way too much fun with this stuff. So
Oh yeah. Yeah, you can tell they've been working together for a very long time.
yes.
So
Thank you, guys.
Awesome. Thank you, folks.
Thanks, everybody.
ah.